In the heart of our solar system lies a star, our sun, a massive sphere of fire that has been the lifeblood of life on Earth for billions of years. It provides us with the warmth and energy that sustains our planet, from the very air we breathe to the food we eat. The sun powers the processes that shape our weather, regulate our seasons, and even provide the energy we use to fuel our modern world. But this energy is not limitless. One day, billions of years from now, the sun will run out of fuel and burn out, leading to a transformation of our entire solar system. So, what if we could harness the sun's energy before that happens? What if we could collect every single what it emits? Could we build something that captures the unimaginable power of the sun itself? A structure so advanced and so colossal that it encircles the star, gathering all its energy to fuel our civilization for as long as we want? This idea, known as a Dyson Sphere, was first proposed by physicist Freeman Dyson in 1960, a concept that, at first glance, may seem too far-fetched even for science fiction. But could it be possible? Today, humanity relies on a wide array of energy sources: fossil fuels, nuclear power, and increasingly renewable resources like wind and solar energy. But all of these sources have their limitations. They are either finite, polluting, or insufficient to meet the needs of an expanding, energy-hungry civilization. What if, instead of relying on the Earth's limited energy stores, we could tap into the greatest power source known to us, our sun? What if we could construct a megastructure that would dwarf anything we've ever built before? One that could power not just our planet, but entire colonies on distant planets. Could we achieve something so grand? And if so, what would it mean for the future of our species? A Dyson Sphere is not a traditional solid shell as some might imagine, but rather an intricate network of satellites, each one designed to capture the sun's energy. Picture it as a swarm of solar panels scattered in orbit around the star, each one harvesting sunlight in a manner that would allow humanity to harness the full energy output of the sun. With this energy, we could potentially fuel all human civilization, power entire space colonies, and explore the cosmos on a scale we can only dream of today. Imagine this. The sun emits about 3.8 times, 10 to the power of 26 watts of energy every second. That's a truly staggering amount, more energy than humanity has used throughout the entirety of history in just one moment. Now, imagine if we could capture even a fraction of that. How much energy could we harness? It's the equivalent of several thousand times more than what we could ever need on Earth. So why hasn't this been done? And why does the idea seem so impossible? Building such a structure would be the ultimate engineering challenge, a feat of scale and ambition we've never attempted before. The sun itself is over 690,000 kilometers in radius, so vast that a Dyson Sphere would need to be located far beyond Earth, somewhere out in the space between our planet and the sun, stretching for millions of kilometers. A full Dyson Sphere would span an area so large that it would dwarf our entire solar system. But it doesn't have to be a solid shell. It could be a loose network of smaller, independent satellites orbiting the sun in harmony, all working together to capture its energy. Still, even with that design, it's hard to imagine the logistics of constructing something of that magnitude. The materials we use today are insufficient to build such a structure. To withstand the extreme radiation of the sun, the incredible heat, and the vacuum of space, we would need to create entirely new materials, stronger than anything we've ever worked with. Graphene, carbon nanotubes, and other future materials may hold the key. These materials would need to be both lightweight and incredibly strong, able to endure the most extreme conditions. This isn't something we can do today, but it's a problem that science is already beginning to tackle. So, while we can't yet build a Dyson sphere, the materials and technologies we need are coming. Even more challenging is the question of how to actually construct the Dyson sphere. We would need to send vast amounts of raw materials into space, materials that are currently too difficult or expensive to reach. Mining asteroids and other celestial bodies could be a way to gather resources for such a project. Imagine a fleet of autonomous robots tasked with extracting these materials from the stars and moons of our solar system, then assembling them into components for the Dyson sphere. These robots would work around the clock in zero gravity, constructing the solar satellites with precision. Over time, these machines would evolve, getting better and more efficient at the task. Construction could become self-replicating, with robots building more robots, speeding up the process exponentially. But once the Dyson sphere is built, the real magic begins. The energy harvested from the sun could be transmitted back to Earth via wireless power transmission, using methods such as microwave beams or lasers. These beams of energy would be directed from space to ground stations on Earth, where they would be converted into electricity. Imagine cities powered by clean, limitless energy, where all aspects of human life, from transportation to healthcare to industrial manufacturing, could run without environmental impact. Energy would no longer be a scarce resource, and the potential for technological progress would be almost limitless. With this energy, we could power not just Earth, but entire colonies on the Moon, Mars, or even the icy moons of Jupiter and Saturn. Space travel would become easier and more efficient, opening up the possibility for interstellar missions. Human civilization would be able to spread out into the stars, colonizing distant planets and exploring the far reaches of the galaxy. The Dyson sphere could provide the power for massive space stations, fuel spacecraft, and allow us to build thriving human communities across the solar system and even beyond. But as with all great advances, a Dyson sphere raises new questions. Who controls the energy it provides? Who decides how it is distributed? Could such power be used for nefarious purposes, to control nations or exploit resources in ways we can't yet predict? The ethical and political challenges of building something so immense are not to be underestimated. A structure of this scale would require unprecedented global cooperation. It's not just a technological feat, it's a political one. If we want to live in a future where a Dyson sphere benefits humanity as a whole, we'll need to figure out how to share this power, how to ensure it is used responsibly, and how to make sure it benefits everyone. And then there are the environmental considerations. The very act of constructing a Dyson sphere could have unforeseen effects on the solar system, changing the dynamics of the sun itself or affecting the planets that depend on its energy. These risks are unknown, but it's a risk we may one day have to take if we want to ensure our species survives far beyond the lifespan of our own planet. And yet, despite the immense challenges, the idea of a Dyson sphere is a beacon of what humanity might one day achieve. If we can overcome these technological, ethical, and political obstacles, we could usher in an age of unlimited energy, sustainable growth, and unparalleled exploration. It would represent a new era in the history of our civilization, a time when we prove that we can not only survive but thrive in the cosmos. The dream of a Dyson sphere may seem far off today, but it is no longer science fiction. It is a potential future, a future that lies within our grasp if we are bold enough to reach for it. And who knows? Perhaps the stars are closer than we think. As we look up to the night sky, let us remember that the universe is vast and that our potential is even greater. Every leap forward, every challenge we face, brings us closer to the unimaginable. A Dyson Sphere could be humanity's next great achievement, a symbol of our ambition, our creativity, and our indomitable will to explore, discover, and survive. So, what if we could build a Dyson Sphere around the sun? The real question is, what could we accomplish next?